This video is a review of the basics of balancing chemical equations, that is, making a BCE, a balanced chemical equation. This is a fundamental skill in AP chemistry that you really pretty much have to be able to do in your sleep. Balancing equations is fundamentally an application of the law of conservation of mass. This law says that the mass of reactants in a chemical reaction will be equal to the mass of the products of the chemical reaction. Or to make it short, mass in equals mass out. Since atoms are of course made of mass, that means that atoms in equal atoms out. So the number of atoms on the reactant side must be equal to the number of atoms on the product side. Here are a few tips for balancing equations. One, I personally tend to work left to right like I'm reading. It just helps me keep from being overwhelmed with a long chemical reaction. I also will usually leave hydrogen and oxygen to the end. Oftentimes they will end up working out when you balance metals and other nonmetals. And we'll discuss more how to do that when we work on balancing redox reactions a little later. But really the most important thing here is you never change subscripts in a chemical formula. Once you've made a formula which exists, you're not going to change it. Change the coefficients in front of the chemical species to get a balanced chemical reaction, or BCE. Here is a simple example. Hydrogen gas reacting with oxygen gas to form water vapor. This is a good place to remind you of the diatomic elements, the 7 elements that always come in a 2-atom molecule when they're by themselves. So the mnemonic for that is Brinkelhoff, Br for bromine, I for iodine, N for nitrogen, Cl for chlorine, H for hydrogen, O oxygen, F for fluorine, or sometimes people use the magic 7 on the periodic table. So let's look at this as a particulate diagram. We'll start by drawing one of each of the molecules. Hopefully you can immediately see the issue here. We only have one oxygen atom on the product side. We can't just put the extra O out here and say, we're good. The product in our chemical reaction is water molecules. So we have to make H2O. Well, if we have 2 H2O molecules, that means we're going to need 4 H atoms. And in order to get 4 H atoms, we must have 2 H2 molecules. So you can see this in the diagram, and then you can turn that diagram into the BCE. 2 H2 gas plus 1 O2 gas forms 2 H2O gas. In ion swap reactions, where we often see complex polyatomic ions moving as a unit, you can simplify your life by treating the ion as a whole rather than counting individual oxygens and such. This requires the ions to stay the same on both sides, as in an ion swap though. So looking at this pretty complicated reaction, starting from the left, I see the ammonium ion needs to balance. There are 3 on the one side and 2 on the other. So I'm going to need to make both sides equal to 6 ions by putting in the coefficients. Once I do that, I notice now I have 2 phosphate ions in the reactant side. I need to fix that on the product side. Once I do that, now everything else balances. There are 2 irons on both sides and 3 sulfate ions on each side. Sometimes when you are balancing, especially with combustion reactions, you may end up in an impossible spot. First, check your formulas if you are the one who made them. In this case, balancing the carbon and hydrogen is not hard. But when I look at the O, I find I have 13 oxygen atoms on the product side now. And I realize this is impossible with diatomic oxygen gas. When you are asked to balance an equation, please don't use fractional or decimal coefficients, only whole numbers. So if I want to fix this, I can do it by multiplying all of the coefficients by 2. If I do that, then my balanced chemical equation will have 13 O2 molecules on the reactant side. Whenever you finish balancing an equation, you should always check your work. 1, you should check to be sure that you have really balanced everything by recounting all of the atoms or ions on each side of the equation. It's pretty easy to miss something, especially if you are stressed or in a hurry. You should also check to see if your coefficients can be simplified. Sometimes you might end up with an answer like this one. You see that the coefficients here, 2, 10, 6, and 8, are all divisible by 2. Like in math class, we always want to have our BCE in the lowest possible terms. So I would simplify this to have 1 molecule of propane gas and 5 molecules of oxygen gas, forming 3 molecules of carbon dioxide gas and 4 molecules of water vapor. Yes, in AP Chemistry, you should always put the symbol for the state of matter in your reaction. You need to get into this habit now so that you will not lose any points later. Remember, you have solid, S, liquid, L, G for gas, and AQ for aqueous or dissolved in water. Now you need to practice using the 5-question Google form. You should get an 80% or better on these questions. If you do not, then you need to re-watch the video or plan to come in for tutoring and then resubmit the form as soon as possible.